Okay. Hello, I'm Kris, and welcome to Embedded Reflections. So who is excited about reflection? A lot of people. It's actually happening, maybe. We will see. And in this talk, I would like to present a bit of motivation for those who are not that familiar with the reflection. We'll take a look into the use cases for reflection. I'm not going to bother with you the proposal implementation details. I will show you what can be done with it. We'll go through the examples. I think that will be exciting. And after that, we'll do the case study, because it's embedded. We'll look into assembly of enum name and see how excited you will be afterwards. But we'll see. It's reflection has positives. So, and we'll sum up. Just as a disclaimer, everything here on the slides have Godbolt links and can be run on Godbolt, including the reflection proposal. It's using EDG compiler. You probably guys know about it. It's actually available and implemented. That's for the C++26 reflection. So hopefully that sounds exciting. Let's begin. Why we would like reflection? There is a lot of use cases for it. One of them is correctness. We can have safe APIs. We can check again the spec. Kind of boring. What I think is the most important is the performance. We can apply things like design by introspection. Who is familiar with design by introspection? Not a lot of people. Who can be on C++20? Not a lot of people. Great audience. Hopefully, I will show that. I will show you one example why you should switch to C++20. If constructor requires, design by introspection allows you to move the condition from runtime to compile time, and that's it. Just switch if you can. I know you can't, but if you could, I would. So for me, what is actually more important, because I'm coming from high-frequency trading, so it's a bit different domain. However, the code generation is the most exciting part for me. So we can generate the switch, for example. That's kind of limited in C++, which we can do. We can pack a struct. That's something which embedded I would think care about, the size, right? But pack the struct in the sense that we can get the other struct with the same names. And the flexibility, also important in, I think, all domain use cases. We can serialize something, right? That's like to JSON or to binary format. And the most important, everyone wants that, just delog it, dump the struct. Dump the struct is the most important part. So quickly, how the reflection can be done. It can be done with the runtime, meaning that you have a runtime string and you can create something. No one cares about that because it's just slow. And the static one, meaning at compile time. And so what we can do with that? We can get the enum name, the member's name, find all the functions in the namespace, stuff like that. So the introspection part is quite easy. It can be done these days in C++ 11 plus. Injection, which is, in my opinion, the more exciting part, is the part where you can generate things like if you actually have a cache. Not everyone has, but if you have a cache, you can leverage data-driven design, for example, for structure of arrays. You can generate the switch, as we pointed out before, and so on. So there's a lot of performance things which you can do with the reflection. How the reflection is being done these days, I'm just going quickly through that because I want to get to the examples. So, code generation, probably someone has that. You use libclang and CMake and try to generate some templates. C++ up to 20, you can do like pretty function and compiler-specific information out of that. Source location in 20, which is also the pretty function. You can do build-ins if you're using Clang. There is a built-in dump struct where you can print the struct, even get it at compile time. There are different compilers like Circle, which has the reflection, and the language support. So meta classes from Herb, that's something he's working on. It's not really ready in any sense. There is a mirror proposal, which was type-based reflection, kind of on the backside these days, because this proposal, static reflection for C++26, is the main proposal which is proposed, and we'll take a look into that. So hopefully that sounds exciting, and we have the introduction. After us, let's begin. What we can do with the reflection. So reflection for C++26. It's value-based, meaning we operate on values, not on types, which has kind of different properties. And the syntax. Syntax is great. So let's take a look. So we have this lift operator in that proposal, which is this caret, which it's kind of like a ref expr. We have a type or a value, and it gives us the meta info object. This meta info object we can get the name of, get the value of, ask whether it's public, and stuff like that. So that's the transition to the meta info, which is like kind of like AST node in the compiler. And after that, even better syntax, which is the index. It's called splicer. It's index operator colon, and you have to close it the other way around, which is the other way around. So we have these meta info objects, and we can go back to values or types. So hopefully that makes some sense. We'll take a look into that example. But it's very powerful because that allows us to do a lot of things using kind of normal C++, right? Because we have these objects, and we'll take a look into that in a second. One thing which is important to point out is that it's const eval based, meaning everything is const eval context. There is no way to do const expert there, so it makes it harder to test in a sense, but that's the way it has been designed for reasons. And what is kind of cool is that template metaprogramming, who is using template metaprogramming? For the record, I would say everyone. But but yeah, it's actually possible with this proposal in a kind of different way when people are used to, where you do type list and try to operate with MP11 or something like that. You can actually do something like that. You have the vector of this lifted indent float. You can use the ranges if you have C++20, or you can do STL or whatever you're using to manipulate the vector, like single for loop in a lambda or something like that. And then you can, so you have int and float, that's the vector of meta info objects, and then you can substitute it, meaning go back to type list in that case via this splicer. So just to phrase it differently, we have a vector, we lift objects into meta objects into that vector. So we have a vector of meta info objects. We operate on them, manipulate them the way we want it. We can sort them, we can drop elements, and after that we splice them back using substitute to the type list. So a future of metaprogramming, potentially it will be looking this way, that will operate just on vectors. And if you're interested, that's actually possible in 20 or even earlier. It's a simple way of doing that. You don't need ranges, you don't need anything. You can just do that because const expr std vector allows that, and const expr static vector or array allows us to do. So you don't need STL to do that. So hopefully that sounds exciting. But let's take a look into main use case, what can be done with the introspection part. So we have a struct foo with some fields, and we would like to get some information out of it. So let's imagine we have this meta variable template reflect. Implementation, you can take a look into Godbolt. It's kind of clunky with the reflection. It probably will change, so it doesn't really matter as much. But all reflection proposals allows that. So you can get the name, you can get the size, value, offset, alignment, all those things you can get at compile time. That's also possible in 20. If you're interested, you can take a look. Those things, or even 17 or 14, all of that is possible with current C++. So the introspection part, it's not that exciting to me personally, but it's pretty cool because it's standard, right? What is not available in that proposal is that we cannot lift the global namespace, meaning you would like to check all the functions in the global namespace, right? What functions I do have, what structs I do have. That's not available at the moment. Potentially in the future, but that's unlikely in 26. But there is, this kind of moment in that presentation is a joke, but it's kind of interesting, so bear that with mind. So if you are on C23, you have embed. Who is excited about embed? Yes, for the record, always everyone. So imagine that we have a struct, full bar, and some function, and you would like to check whether in the file you are in, you have those, whether you have a full bar or function or something like that. Again, it's kind of a joke with embed, but you can do that. And the trick is that the first line here is the self. So you embed yourself a file. So you do dash embed file. That will give you the string view of file you are in, and then you just have to not find what you actually find in, because that will be part of the string you are looking for, right? So if you write meta contains will be in it, so you have to dismiss that part, but you can find everything you want in the file. Possible, not advised. I'm not advising that. I'm just wanted not everyone to go asleep and really think that through. What consequences embedding yourself may have. You can imagine, implementing the whole parcel in C++, const expr of C++, and have a meta compiler of C++ in C++, or C. Or C actually happened. I don't know whether you've seen. C can be compiled in const expr. So here we go. Okay, so the exciting part. What else we can do? C++ injection. So if everyone knows here, I bet. So we have struct, which is unpacked. It has short, in, and bool. It's not correctly layout in the size order. So the size will be 12, right? By default, it would be nice to be able to say, pack all my structs to the size I want, unless they're GNU packed or something like that, where I actually get them from the wire and I want them unpacked. So with the reflection, you can actually inject members into a struct. So you have a struct which is not defined, and you have the syntax to inject things into it. So that's pretty cool. So you can pack structs which are unpack. But what is really cool about it, it's the last line, and the size will be 8 here, right? What is cool is that you have the same members, right? So you have the I, S, and B members in the new struct. Because this thing is totally possible with the two-tuple. You can do two-tuple trick with structure bindings, get the fields, and sort them by size in 11 or 14, whatever. But you cannot get the names in the new struct, right? You cannot do that. You will have to get them by number. So reflection allows to do that. So that's pretty cool. Who is aware of stateful metaprogramming? For the record, okay, no one. Not a lot of people, not a lot of people. Stateful metaprogramming is this weird trickery in C++ from 03 that you can actually have for example, meta counter, which is different each time it's like a underscore counter, but in the metaprogramming space. So you can have, for example, next, and if you ask a second time, you'll get a different number. So that's possible in this reflection proposal. It's also possible in C++, but proposal actually makes it valid, because in the proposal, without the proposal, you have to do friend injection. I'm not going into details, but if you're interested, happy to talk about it afterwards. So what you can do as well, if you are familiar with metaprogramming, you can do kind of stateful code injection into your program. So imagine a global type list which, like, functional, metaprogramming is functional by default. But imagine that you have a global state, and you just add in, as you go with the code, push back, push back, push back, push back, and after that, at some point, you want to get the type list, what is at the end of that file. And that will be what is encountering the file. So like normal ifs won't affect that. If you have if something, that will still be encountered by the compiler, so it will be added to the type list. So it has a lot of interesting use cases. Like you can do the borrow checker, a lot of crazy things with that, like virtual dispatch with templated calls, like you name it, you can do that with that. But up to 26, it's kind of not encouraged because it's using thread injection trick. But 26, reflection proposal acknowledge that use case. I really like it. It has a lot of performance benefits as well, if you think about it. So what else is not allowed in that proposal, which is kind of a bummer in my opinion, is that you cannot generate these switches in code at the moment. There's a different proposal which will be discussed in a few days, actually, in Tokyo, where there's the meeting, which allows that. I think that's like super important use case for reflection, that you can generate some kind of code out of your compile time knowledge. Because usually you would have to use generators for that, and reflection is kind of the replacement for it. So here, I pointed out a bit of syntax because it's hard not to show it without the syntax, but I wouldn't be struck too much about it. So they use percent, and you call these gen cases. In that case, we want to generate the switch case for enum values. And there's more syntax here. You have this kind of builder, and you can append case, append return, and stuff like that. So you can generate the code. So on the right, you'll see that it generates case and return. So I don't like the syntax much, but I think the premise, the power is there. Who would like that? That would be pretty cool, right? A lot of people like that. The idea is decent. Possible in C++ since forever. You just have to do nested switch. We actually will have an example of that. It's not ideal because the optimization depends on your compiler, because it's a nested switch. So whether it will be flattened properly depends, and it's not always the case. So I have to be careful about it. But if you could actually control what your code should look like, that would be awesome. Okay, so that was the part about the reflection. I hope I give you some examples. There's tons of more. I didn't dig into the implementation details because they will change, and to be honest with you, they're messy as it stands. But just to sum up, there's a proposal for 26. It will be discussed in actually a few days. If it will get through the next stages, maybe it will be there. It has a lot of potential. It won't cover all the use cases. It won't cover the generating part, but it will have the basic introspection and basic injection, and it will allow meta-programming in a different way. Okay, so let's dig into enum name. Who is using enums? Yeah, that's the crowd. Everyone is using enums. So we have simple enums, right? We have different enums which are more combined. These enums were chosen specifically for the code generation part because I'll show how GCC is generating that and why the values have to be in a specific way to get it to do what you want. And these are flag like scoped enums, and there are flag enums, which we won't be talking about it because they're like very interesting on their own. But it's interesting to know because the proposal didn't tackle them at all. And all these ideas here, because it will be about performance and how to generate the code, are applicable anywhere if you have the hardware. Okay, so let's take a look how the enum name is currently implemented in the proposal. So it will be a bit of syntax here, sorry about that, but let's see. And it worked obviously at compile time. You can always static assert. That's not a biggie. That's actually the easy part. The most interesting to me actually is the runtime part. So I'm looking at it and I'm seeing the first line and I see string. And like I would say not the best start for the enum. Then we have the expand, which is a workaround. We'll see why they have it. And then this if, and this splicer is to get the value identifier to compare, and then we get the. Whoa, did you get that too? Sorry, I just got an info on a different screen. So yeah, it looks pretty easy, right? I see a lot of issues with that, but there's a proposal which they tried to fix some of the issues. So this expand and splicer, that was kind of weird. There's a template 4 proposal to go through, it's called expansion statements, where you can go through the tuple without the apply. You just generates code for each element. And that's pretty cool because it allows you to early exit, right? If you do the index sequence or something like that, if you apply, with tuple, you can't early exit. Right? You have to do the expansion till the end, or store it as they did in the string, which kind of sucks. But here you can do that. But that likely won't be in 26, so I don't know what they will do. And I don't know whether the reflection will actually have only the raw, reflection part, or whether it will be standard library like name. We'll see. They're not decided yet. So who will think that the generation of that code will be great? Will be like assembly of that will be good or bad? We have if-else strings. Yeah, I've taken a look. I can't show it because it's just, really huge. I'm not claiming it's EDG. I think it's GCC is the backend, but I'm not sure. It's on the compiler explorer. But you can see that, well, that won't be, embedded use case or any use case, in my opinion, if you care about any sort of performance of the size. So I've taken a look and tried to show the trade-offs of that. So compilation times, I think here it's fine. Because AST nodes, reflection is really fast, because it just takes AST node from the compiler. So that's awesome. What about the performance? Well, if you want an enum name, I would claim that probably switch case is the main default, not the if-else, because if you have 50 cases, you don't want to branch all the time. But it depends, right? I would claim that it depends on your use case or what you want to do. What about the binary size? Who cares about the binary size? Yeah, that I got it once at least. So, return type, like std string is probably not good for binary size. Whether you want to share the buffer between different enums, like if you have two enums with the same name, maybe you want to share the buffer between them, is you know that upfront, right? So whether you want to return a string view, you want to ignore the size, the size of that string return. Do you want to dismiss it or not? How you handle error cases, like is there unknown value? By default it was empty, maybe I want different one. What about flag enums? Like that's like, would you like to be able to have the flag enum name printed if you have a flag enum? Or in that case that will be nothing because the flag enum won't match. So there are a lot of cases to consider here. So I decided to take a path into optimizing that just for fun, and that which will be just a different trade-offs. So I looked into that and decided to go a bit different way than the standard example. So it's C++20, but I think it's important to have facilities in the standard which are available to everyone. It's like it's pointless to have a reflection if you can't really use it. At least they didn't throw an exception, which could happen. So I started with the fixed string view, which is not really a standard thing, but you can take a look into Godbolt. I'm not going into details much, but it's like a string view at compile time with the size at compile time. So the first thing which I think is important when you design code which has to be flexible, either for performance or the code size or something like that, you have to have that kind of policies, right? If you're not familiar with the syntax, enum here, enum auto is like C++ 20 concepts. So what we are getting here is just get the enumerators from the reflection, and after that we try to apply the policies. Who is using policies? Policy-based design. Not a lot of people. Encourage if you want to be flexible. So who is using if-else? Oh yeah. Okay, so if-else. How will you implement if-else? Well, it will be the same as before. So we do this template for, because that's C++ 26, but if you have C++ 03, you do 4, right? And you just move it to runtime, and you're still good to go here. What kind of code that will generate? So the code is not terrible, right? It will just generate the jumps based on how many cases we have. And notice here on the bottom, there will be the string errors for the enum cases. It's maybe not that important to understand. It's x86. It's not ARM or anything like that, but assembly is similar. So as you see, the code maybe it's not bloated, but it will be if you have 50 cases, right? It will be a lot of jumps. There will be a lot of code bloat in that case. So can we do better? There are cases for jump table, right? In my opinion. Who's using jump tables? Not a lot of people are using jump tables. Interesting. So jump tables are good for performance if they fit, if you have a cache in your cache. If you don't have a cache, I believe they also good. So jump tables will allow us to generate like an array, and then based off the index of the enum, just jump to the specific case and get the value. There's no comparisons, no jumps, nothing like that. But what we have to do, we have to verify whether the enum is a valid range. Anyone knows what's the valid range of enum? Shout. Valid range of enum. There is a standard case. So if you have an enum, the min and the max value, everything in between, no matter whether it's part of enum or not, is the valid range. Everything otherwise is not. So meaning if you try to static cast an int which is below the minimum value, that's not a valid, it's undefined behavior. And the same otherwise. So you have to take that into consideration. And what you have to do, yeah, I think like I'm really killing you with the templates here. I'm sorry about that, but the idea here is that you generate index sequence, you go through it, and you generate an array. I wish we have better ways to express it. If you really want to write, compile time code in C++, it's difficult. It's kind of verbose, but you can do it. And I wanted to point out, because a lot of people make that mistake, if you want to align an array to a specific offset alignment, you cannot do align as array, you have to do a struct, because you can only align struct, right? So important if you on x86, if for example. So what do you do then? So you have this buffer. In that case, we'll have just one single buffer, because I noticed that the performance of that is much better than having cases, different buffers separately for enum names. We will have the size. We won't have the 0 terminated string literals because that's kind of 1 byte. You can either put a 0 or you can put the size. I prefer the size because that's information I'm not going to lose. And then we just jump based on the case. We have to minus the min, but it's not that important. What is important is what is actually generating. So it's generating that. There's no jumps besides the valid range, right? That's the case for invalid range. But after that, we have just jump table, which is just 2 bytes into that buffer. And this buffer here has the size and the value, because it's like a string view. I use this fixed string view. Instead of 0 at the end of the buffer, I have size at the beginning, which I think is more powerful because it gives you more information. You don't have to do stern len to find the length of the buffer, because you have that information and then you throw it away when you return const char, for example. So that's pretty cool. Switch case. Who is using switch case? Yes. Who knows how the switch case works? Okay, well, maybe I will show something. So I've taken the look, I took the time and analyzed GCC tree switch conversion.ccc, which is the implementation of the switch case. Very interesting read. I encourage everyone to do it. It's as interesting as the standard to read. But it has really interesting cases. So how the switch case works in GCC, and very similar to Clang, I'll point out the differences, is that it tries to identify the clusters. So you have a lot of cases, it tries to identify clusters which can do something with. And it can generate the bit set, jump table, or the decision tree, which is the if-else. So if it can identify the jump table part, it will do the jump table, everything else will be if-else. If it can generate the bit set, this part will be bit set. So how is that being done? Bit set, it's something which is not applicable to enum name, but if you have the single cases, it will generate the bit mask, and it uses bit set instruction to get it, like different cases, to one single output. Bit set is not available on ARM, so if you're using ARM, you don't have it, it will generate some shifts over that. So bit set is interesting, but it's not that interesting in our case. But the code, which you can take a look into, it will be just one instruction, move bit mask into the register, and after that, a BT instruction. That's it. So it's pretty cool, pretty fast. Only GCC is doing that. Clang doesn't do that, just for the record. And that's how they define whether it's beneficial, because GCC always verifies whether the case is beneficial to do it or not. More interesting part is the GCC and the jump table, sorry. And GCC and Clang do the same thing. So, who compiles with OS? Not that many people, surprising. Who is compiling with O3, O-fast, O2, O0? Who is not compiling? Okay, so depending on whether you're compiling for the size or for the speed, you will get the different ratio in the jump table case. And the ratio is the differences between the cases. So if you have 0, 2, 5, 50, you have the difference between those cases like 2, 3, and 47, let's say. So if the ratio for size is 2, they have to be really not sparse. So 0, 1, 2, 4, 7. 7 will be not wrong. So it won't generate jump table for all of it. It will generate for this part of it. If it's for speed, you can have the sparsity 8. So you can have 1, 8, 15, and it will still consider jump table as an option. But then it tries to verify whether it has the heuristic. All of that is heuristic. It will try to compare the count of the comparisons. So it will try to figure out how many comparisons I would do and how beneficial is the range of the jump table. So there's a heuristic there, and it says yay or nay. And then also it will prune all the jump tables which are less than 5 elements, unless you have these some obsolete. I couldn't find the hardware which has it. I know ARM and x86 doesn't have it. It's called case SI. In that case, it's 4. Apparently, there is a platform architecture which has switch case support in some form. I couldn't find much information about it, but I know it's nothing anyone is using, so probably you guys using that somewhere. So you might be considered that the 4 elements will be the case in which the jump table is not beneficial in GCC. And otherwise, what it's doing is just getting the if else, if else, if else, if else. But what's really interesting, it's doing that based on the probability. And this probability you can apply. So if you know that one case is more likely than the other one, you can put built-in expect with probability, and you can set this probability yourself. So you can, or the order is also important, right? The order is the default, unless you know exactly this case is 50% and this case is 10%, 10, or this is 90 and everything doesn't matter. So we can force that output with that flag. And you can also do that by profile-guided optimization. Quickly, how we generate that. As I pointed out, in order to generate switch in current C++, you have to do it with the default case. Default case is going back to the calling yourself. And here, I don't know whether you notice, I use lambda. Lambda, if you want to call it recursively, you have to put your name in the beginning, unless you have deducing this, which is 23, and you call yourself with the name of yourself, and then you can call lambda recursively. Very nice syntax for that. But yeah. The main idea here is that in the default, we generate recursively the next case. So what that will generate for enum name? It will generate the same, and the enum name is just two values. Same as if else. Why? Because we have 2 enums, 0, 1, didn't generate jump table because it's less than 5, didn't generate the bit set because it's not applicable because the names are not going to the one case. So that's the case. And after that, for the combined one, which is more problematic, but it can generate the jump table and the special case. And that's what I wanted to point out, why switch is awesome, because it does that per cluster. So we noticed that we have 8 cases which are jump table worthy, and there's one case which is not, it can't be there because it's too big and too much sparsity would be involved, but it just do the if else for that case and after the jump table. So switch, pretty cool. And that's the strings. But, and therefore I picked this, when I pointed out these enums, I picked the enum which has the sparsity 10, because I compiled with all3 to see what it will do. I could have picked 9 because I know, but I picked 10 just to see what we'll do with this enum. It's the same number of elements, it's just decision tree, if else, if else, if else, if else, if else, if else, if else. Also generated in GCC incline. Yes? Oh. At 16 every time? Yes and no. And that's a great question. I've seen it being done. It's a different optimization before the switch case, which can lower it that it's the transition is sequential, and it can lower it, but unlikely, very unlikely. I've seen it though happening, but it's not in the switch case code. It's before that. There's a different path which somehow may generate that propagation that will divide by 16 and it just do whatever, right? Something like that. But unlikely, unfortunately. Would be great though, but that's actually perfect introduction to why we have to go further if you want performance. if you want to perform, like switch case won't generate hash. Like it won't generate hash, sorry. No matter how you try, compiler won't spend minutes or hours or something like that to generate the hash if you want. And who's familiar with minimal perfect hashing? It's basically when you map all your keys into range of the number of them. So from, like, you have a key, it will be have 0, 1, 2, and whatever. You have different hashing, not important. Another map is like universal hash. gperf, who's using gperf? Someone. That's the perfect hash. And there are options here. I'm not going to dig into details because I have little time. But what you can do, if you have x86 instruction, unfortunately it's not on ARM, it's on Zen 3 on AMD, but it's on x86. It's called parallel bits extraction. It's called PXT. And you can do something like that. It's a pretty cool instruction. It's not really that important to know it. It's important that there's a hardware acceleration SIMD for it, which takes the word, takes the mask, grabs the one which are ones, and then it's compressed. It takes 3 cycles, which is extremely good, right? Because, like, I don't know, if you compare it to division 10, 20, whatever. So 3 cycles just to get that thing. And why that's useful, let's take a look. So we'll consider here a new use case. And notice this GNU target BMI2, which is for specific compiler architecture feature enabled. Pretty cool. If you don't use it, I would advise it. We generate some keys. It's not that important with the index and offset. And we find the mask, and we find it at compile time. So usually compilation times until Odin, find all these tricks with Quasir was based on the template method programming and was kind of limited there. You got up to 1,000, and here we push in the envelope a bit further because we try to generate hash at compile time. So it's kind of there's a computation expensive thing. It's not really generating templates. It just a lot of things have to happen at compile time. So how we do that? We have, like, I don't know, 32 bits mask, and we just enable each bit and verify whether all keys will be unique, meaning is that bit important or not? And just go one by one, like finding a hash. That's an alternative, right? It's like if you want to find a hash, there's a lot of computation going to find a hash. You find this hash, you have the index, you look at it like in the jump table, and you're done. And that's very powerful if it comes to the performance. I want to stress that again, that it takes a lot of time. And with ConsExpert, that's actually pretty fast to compile. It takes like less than a second to compile to find a mask for enum which has 100 values. But yeah, it took a lot of time to optimize that, so it's not that easy to do that. But what it will generate, and that's the power of hardware accelerated code. We generate just this one instruction, pxt, and just get the index of the jump table. So that's our jump table, which will point to the index. That's our buffer. And we use the same trick with the, like in the switch jump table. So we have the size and the name. But how that will look for different enums? Well, it will look exactly the same. The only thing which will change is the index jump table and the buffer, right? Because that has to change. And why I'm showing that? Because, for me, the performance really matters. Maybe not for enum name as much as for other things. In HFT space, that would be, the symbol name, like NVIDIA or something. You want to grab it fast before everyone else. So if you have this combined two, that was the weird use case for switch case when it was like, if else couldn't figure it out. It could figure out that it's divided by 10, do it, but it didn't. That would be the output, right? It's the same thing. It's just a bit of jump table and a bit of buffer. We go 3 cycles instruction. That, like, I think that's all of that is just 8 cycles or something like that. We have move, pxt, move, add. So few cycles. and we done. And doesn't matter how big the enum is and what it is. And it fits in the cache, it will fit in the cache. So if you have it. So just to sum up, because I'm over time. So in the end, I would like to say that by default, I would use switch case, not if else. If I have not just a few cases, right? Because switch case is powerful, let's point it out. It can do a lot of things. If else won't, if else will do the comparisons. And there are heuristics in GCC, which and Clang, which helps. But they only heuristics. If you want to control that, you have to do the policy, in my opinion, because otherwise, you know, if you switch the compiler, you switch the version, you switch the use case, you know, increase the number by one, and never performance is gone or the size is gone. It's because, you know, you are out of luck. So we can control that if you have a policy, and here is a policy which is similar to GCC, just different. So if you have less than 4 cases, we generate if else. If you have the sparsity less than 4 and 32 cases, doesn't really matter. I just took it arbitrary. We generate jump table. If we can execute the hash, we execute the hash. And if we can't, we generate the switch, which will generate what it can as the best. And in my opinion, that's way better if it comes to getting the reasonable results out of it, and we can control it, right? And you can say what you actually want out of it, and not relying on the fact that if you want to compile with different version, different flag, different results, right? So that's powerful. I think, like, I love C++ because it gives control to the, you know, programmers, and if you leverage it, you might be happy about it. So just to sum up, static reflection is awesome. It enables a lot of use cases for optimizations, and also adds a lot of complexity, which I try to avoid to show. If you look into the implementation details, oh wow, it's nothing which I've shown here. If you consider what I shown complex, well, take a look into this proposal. It's a lot of magic happening there as well. But static reflection is powerful. Everyone kind of wants it. Everyone wants something else, but all in all, I think it will be powerful. In the state which it's in, I don't know whether it's powerful enough to be supported in the embedded world because they use strings and stuff like that, but that may hopefully change. I pointed to them that fact, so maybe it will be respected. And performance-wise, there's no silver bullet to the performance, just trades-off. I like to say that because, yeah, there's no one specific way. Switch is not the case, hash is not the case, if else is not the case, depending on your use case. And you have to always measure. And what is the most important part? You have to measure in your application, your use case. Micro benchmarking is really misleading often. So with that, let's embrace compile time reflection when we have it, if we have it. If we meet here in emBO, C++ 2029, 6, I don't know, 32, 50, maybe we'll have that, maybe we'll talk differently. Maybe actually differently. We'll have reflection and you guys will be using it. And if you're interested, that's the proposal and that's the library. So with that, thank you.
Okay, are there any questions? Okay, yeah, there's one.
Stud format. Yeah, I like naming is hard. Naming is, you know, in the proposal is actually called enum to string. Because standard has 2 string, right? But yeah, STD format formatter could be a good solution for that too, right? If you want to put in the formatted string. Oh yeah, you can add the formatter, right? It's like you can add the all-stream operator and stuff like that, right? For anything you want. You can dump the struct with that as well. All right.
Any other questions? Okay, so thank you very much, Kris.